When you first look at raw data, it's just a mess, right? A jumble of disconnected clues. But what if you had the right toolkit to piece it all together and actually solve the case? Well, in this explainer, that's exactly what we're going to do. We're equipping you with the advanced SQL skills to become a true data detective. And it all starts with one big question. So this is the fundamental challenge, isn't it? You've got all these tables, all these numbers and text, but the real magic is in the story they can tell. We're about to see how advanced SQL helps you uncover that narrative, turning you from someone who just manages data into someone who tells its story. All right, so where does any good investigation start? You got to gather and connect the evidence. In the world of data, our clues are often scattered across totally different tables. So our first tool, the joint, is how we bring it all together so we can finally see the full picture. Now, don't let the word join intimidate you. It sounds technical, I know, but at its heart, the idea is super simple. It's just a way to match up related things from different lists. And this party analogy we see here, it makes the whole concept really click. Okay, sticking with our party theme, how do we decide who makes the final cut for our list? Well, an inner join is kind of like the exclusive list. It only includes guests who are on both the guest list and the gift list. Perfect match. A left join, on the other hand, is way more inclusive. It shows everyone from your original guest list, and hey, if they don't bring a gift, that spot next to their name is just left blank. Simple as. And here is how we actually build that master report. Let's look at the code. We start off by selecting the columns we want to see, but the key part, the real action, is that inner join keyword. We're telling the database to join the claim table to the car table on the car ID they both share. Then we just chain another inner join to connect to our client table and one more to link up with the address table. It's like we're building a bridge between 4 separate islands of information, one connection at a time. And here is the payoff. Look at that. By connecting those clues, we've created a single unified view. We don't just see a random claim amount anymore. No, we see that John from New York, who drives an SUV, made a specific claim for $542. The data is now telling a coherent story. And that is how joins transform fragmented data into powerful insights. Okay, so we've connected our clues. That's step one. But the very best detectives, they spot the subtle patterns that everyone else misses. Our next tool, window functions, is like our magnifying glass. It lets us look closer at our data without losing the bigger picture. This classroom analogy is just perfect. Think about it. A standard group by squashes all your data down into one summary row, like only getting the class average height. You lose all the details about the individual students. But a window function is completely different. It lets you do a calculation across a whole set of rows, like ranking students by height, while keeping every single student, every single row right there. You get to see both the individual and the group context at the same time. A classic example of this is creating a running total. Let's say you want to track your company's total claim payouts over time. A window function goes row by row. It takes the first claim, $542. Then it adds the second claim to that total, bringing us to $1,747. Then it adds the third, and so on. It gives you this awesome cumulative view that's just incredibly useful for tracking trends. Let's make this real with a business challenge. Imagine your manager comes to you and asks, for each type of car we insure, SUV, sedan, truck, what was the single largest claim we had to pay out? This is the perfect job for a ranking window function. And here's the code that solves it. The magic is all in that rank function. We use over to define our window. Now, partition by car ID tells it to create separate independent rankings for each car type. Then, order by claim amped disc sorts the claims from largest to smallest inside each of those groups. And finally, qualify rank equals 1. That's a powerful little filter that just gives us the number 1 top-ranked claim from each group. And boom, there's our answer, clear as day. The single highest claim for an SUV was $9,500. For a sedan, it was $7,200. We didn't just get a long list of numbers. We answered a specific, really valuable business question by finding those hidden heavy hitters in each category. That is the power of window functions. Okay, our detective work has been brilliant so far, but our notes, they might be getting a little messy. Our final tool, the Common Table Expression, or CTE, is all about organization. It's how a great detective takes a complex investigation and lays it out in a clean, logical, easy-to-follow case file. Just look at the difference here. We're trying to find cars with a resale value below the average for their type. On the left, you've got this tangled subquery where you have to read it from the inside out. It's a real headache. But on the right, the CTE is like a clean, simple recipe. We start with the keyword with to create a little temporary table called av values. Then, in our final select statement, we can use av values just like it was a real table. It's so much easier to read and understand. So yeah, a CTE is basically just a two-step recipe. Step 1, you use that with clause to define your ingredient, which is just a temporary named result. Step 2, you cook your main dish by writing a final select statement that uses that ingredient you just defined. It's clean, it's logical, and trust me, it's way easier to fix if something goes wrong.
So there you have it. We've just added 3 incredibly powerful tools to your Data Detective Toolkit. Let's do a quick recap of what you've learned to really lock it in.
So first up, you have joins. That's your essential tool for connecting clues and building that single unified view from scattered data. Second, you have window functions. That's your magnifying glass for spotting those hidden patterns, like rankings and running totals, without losing any of the crucial details. And finally, you have CTEs. That's your method for organizing your complex logic into a clean, readable case file that anyone on your team can pick up and understand. All right, now it's your turn to put on the detective hat. Here's your next case to crack. A full join shows you everything from both tables, matching them up where it can. So, how could you use that to find 2 really crucial pieces of missing information at the same time? Cars that have never, ever had a claim, and claims that are somehow missing their car data. It's a great puzzle to think about on your SQL journey. Thanks for joining.